On the last part, we focused on making our CPU header file and our CPU initialize function. For this part, I want to focus on our load ROM function so we can get our ROM loaded into the proper areas in memory, and then we can actually run a game once we get all the rest of the CPU done. So we already declared bool load ROM in this file, so we can go ahead and go to our cpu.c file, and we can go ahead and declare it here. Bool load ROM. It's a constant char pointer path. This is going to be our actual file path that we need to pass to the function. And then our CPU pointer, which we'll need to pass as well. Pretty much every function from here on out is going to need at least a CPU pointer, so just keep that in mind. For now, I do know that we're also going to need some includes. So let's go ahead and add on top include the standard library. So it'd be standard lib.h and then include standard io.h. We're going to need these for reading the file and for printing any errors to our console so we can keep track of how things are going. Okay, let's get started. We're going to go ahead and make a file pointer. We'll just call it ROM. And then from there, we'll do a long file size. We'll just store the file size into this. It's just a long integer. For ROM, we will set it to fopen. We'll do path, which is going to be our file path, and RB. So RB stands for read binary. We're going to need to read this ROM in binary for it to work properly. If we select anything else, we may run into issues, so just remember RB for read binary. Go ahead and do some error handling. So what this error handling does is it just says that if ROM equals 0 or has nothing in it, we print this error to the stream and then we return false, and we can handle the error in the main function, which is where we're going to be calling load ROM from. Okay, so next we need to get our actual size of the file. So we're going to do a size check. The way that I like to do it is using fseek. You do ROM 0 and then seek end. Basically what this is doing is it's kind of like a cursor. It's incrementing through the file until it finds the end of the file. And then from there we can set the file size equal to ftel, which is where that file size will be stored after fseek is ran. Then we can do a rewind, which will put the cursor back to where it was before we did the fseek. Now we'll check that file size. If it is equal to or less than or equal to 0, or if it's larger than the max ROM size, which we will declare here in a moment, we can print to standard error invalid ROM size. You can really write anything you want, but I figured that's just a good way to put it. Close ROM and then return false. So I actually realized that earlier I added the defined max ROM size off camera, so apologies for that, but we'll go over it here. The max ROM size is pretty self-explanatory. The 4096 is the maximum size that the Chip8 can hold, right? And what we know from the Chip8 architecture is that the ROM loads at 0x200. So anything inside that address space at that point is going to be what the ROM can be. So we're taking 4096 and subtracting it by hex 200. And that's going to be our full ROM size that we can use for the Chip8. Okay, so now we need to actually read the ROM file into our memory in the CPU structure. So to do that, we're going to use size t, and the reason why we're using size t is because the size can be different every time, so we don't know exactly what the size of the ROM is. It can be different on every load, depending on the ROM that you load. Bytes read equals fread, and what we're going to do is we're going to read this file into memory at 0x200. I'm going to put 1 here. So this argument just says how large is each element in bytes, and the size is 1. File size, which is the size of our file, and then ROM, which is our actual ROM path itself that we loaded in earlier. And then from here we can close the ROM because we're done with it. Now, it's smart to do a final check to make sure everything is working properly. So we'll go ahead and add a little bit more code here. Make sure that bytes read equals the file size that we had from the ROM originally. So cast that to size T, and then we'll say file size. So we just want to make sure that it's equal. If it's not, then we know that it failed. So we can go to the standard error stream. We can say ROM read into memory failed. So we want to keep things specific so we don't mix up the errors, because everything is related to memory. So you don't really want to keep things too similar. Otherwise it might get confusing when you're trying to trace down an error. But I digress. All we really need is this to handle it. And if we know everything is good at that point, then we can just return true and we're golden and ready to go. Okay, now that we have that file saved, we're going to go ahead and make our main file finally. So I'm just going to call it main.c as usual. And then what we're going to do is we're going to include the CPU header that we need. And of course, we'll add other headers as we go. But for right now, we'll just add that. So our main function is going to take in a variable for our path file, so then every time we launch it, we can have a new path. So we're going to do int argc char for the pointer argv. And from here, we want to make sure that we only have two arguments, which one of them is the program and the other one is the actual file path itself. So we're going to do a check here just to make sure it's all good. If argument equals 1, which means that it only passed the name of the function, or argument is more than 3, which means that there's more than just the file path, then we can do the classic usage return. Usage chip8, and then we'll say, we'll do quotes here, we'll do file path, we'll make it capital so it looks cleaner. And we'll do a new line, and then we'll return -1 for failed execution. Now we need to bring in our includes here, so we need the standard IO header, so I'm going to go ahead and put that there. And then from here we can continue. Char path buffer, we're just going to make a static array, we'll just make it 256 just so we know that it's going to have enough room to fit our actual file path. And then from here we'll do a string copy. We'll take the path buffer, we'll take the first argument, or not the first argument, this is actually the second argument because of the off by 1 problem, and then the size of path buffer -1. And then from here we will make the path buffer final element our null character, our null terminator, just to be on the safe side. So we avoid any possibility of a buffer overflow. Now for this, we also need to add our include for the string copy function. So that's just going to be string.h. Okay, so since we're already in the main file, we may as well go ahead and add a couple things. So we're going to make our CPU structure here, and this is going to be the one that we're going to be passing through the entire program. And then we'll go ahead and call the CPU initialize function and the address of CPU that we just declared. And then from here, we'll go ahead and run our load ROM that we just created. Path buffer, address of CPU. And then from here, if we run into a problem, we made it to where we put it in an if statement, so if it returns false, so we can handle our errors. Error failed to load ROM. And then from there we'll return -1. Now this is going to be on top of the original message that we put. I just like to handle it this way because I think it's a little bit cleaner just to have it in the if statement, just to handle it right then and there. But it's really up to you on how you want to do it. for me, I'll just leave it like this. And for the main, that's pretty much all we can put in here for the time being. Because for the next part, we're going to need to start working on our opcodes and everything else. And then later on, we'll add the display functions into main so we can start showing things on screen. I really wanted to keep things simple on this one because I wanted to make sure that for anyone who hasn't done file loading like this, they kind of get an idea of how we're doing it. I find it to be pretty simple in C, but there are some things that can go wrong, like you need to make sure that you're handling your string copy properly to make sure that there's no buffer overflow, which is why we put the null terminator at line 13. But from here, we'll go ahead and add the last of our functions. We'll just add the actual declaration so we can work on them later. So we need to put program cycle, fetch opcode, execute opcode, and load ROM. Sorry, we already did load ROM, and update timers. From here, we will go ahead and do void program cycle, and then CPU. Easy enough. Same thing here. We'll do fetch opcode, CPU. Didn't autocomplete for me for some reason. That's fine. Right, this is actually a return type of unsigned integer 16. So that's on me. I have a habit of just typing void sometimes without thinking. And then for our last two, I'm just going to go ahead and copy and paste them. So our last two are void execute opcode and void update timers. So now we have everything pretty much ready to go to start writing our opcode functions. Everything that we need to do will be in all four of these functions for us, and it'll come together later. At the moment, it may look like it's just kind of scattered all over the place, but really the thing to remember is that this is going to be where our cycle is handled. Fetch opcode is just going to get the code for us and return it as a 16-bit. And then from there, we'll have all our execute logic in here, and then our update timers logic in here. For this tutorial, I really wanted to keep it short and simple. I didn't want to get too in the weeds of things, just so everyone has an idea of what's going on. If you have any questions, please leave them in the comments below. I'll do my best to answer them. And thank you for coming to part 2. Hope to see you in part 3. Have a good one.